Okay, you got it right, Ms. No?
Yes, I just did. So it's because I asked you to remind me that I remembered. Alrighty, so let's go ahead and start. And first, I want to just go through and solve a system so that we all remember the steps. So first, we're going to make D11 equal to 1, where D11 is the first coefficient. Then we're going to make D21 equal to 0. That's the element right below D11. Then we're going to make D221, which is right now currently a -2. And then finally, we're going to make D12 equal to 0. So that's the order. And using that order, we see that our initial matrix is 4, -1, 1, 3, -2, -3. So what is a good way to start? If our first goal is to have D1 equal to 1.
And you can subtract.
Absolutely. If did -3, 1, and we're going to do this by adding -1 2 to row 1. So let's row 2, and I'm just putting row 2. It's not the one. It's the one that changed. So 2, it's 3, -2, -3, -1 times row 2, positive. Current row 1 is 4, -1. The new one. So -3 plus 4, 1, 2 minus 1. So we started -4, -1, -2, -3, and using the command -1 times row 2 plus 1 gives us a new. We get our new 1, 1, 4, and row 2. Just so first goal. What's the second goal?
To make it a 0, the 3 is 0.
That's right. And so since D2 equals 3, 3 equals -3. So what can we add to get negative?
-3.
We're going to add -3 times row 1, row 2 to get 2. Let's work that out. So let's see, current when then we have -1 times 1 row 2. Let's see, the current row 1 is 1, 1, 4. It's negative. This should be a 3. What is negative times row?
It'd be -3, -3, and -12.
Awesome. Thank you. We still have row 2 negative 3. Second rows get
0, -5, -15.
excellent. What right at this step, whether or not we're going correctly. You know,
15 can divide equally into 5.
-15 divided by -5 is integer, not a fraction. We're feeling confident that we add correctly. New matrix, let's see, our new row 1, pardon me, our new row 2 is 0, -5, -15, and we still have 1, 1, 4 for row 1. What can we do? Oh, so let's see, we've completed our second goal. What is our goal?
To have D21 0. Now you have to do that one has to be a 1. Yeah.
That's right. Very good. And how can we get D22 to be 1?
Divide 5 over 1 or 1 over 5, excuse me,
Yes,
on both over the in the 5 and the 15.
very good. So, and yes, we're going to use command -1 over 5 times R2 gives us a new R2. And this is exactly the same as dividing by -5. So let's see, -5 times 1 over -1 over or 5. It's 1. What is -15 times -1 over 5?
3.
Good. And we still have 1, 1, 4 in row 1. And what's our last goal?
Make it a 0.
Good. So we want fourth goal. D12 equals 0. What is D12 right now?
A 1.
And let's see, 1 plus what equals 0?
-1.
All righty. So we're going to use the command -1 times R2 plus R1 will give us a new R1. And let's work that out. So let's see, we have the current R2 and then -1 times R2, the current R1 and the new R1. What is R2 currently? Oh, I see, it's 0. 0, 1, 3. So what is -1 times row 2?
0, -1, -3.
Thank you. And currently row 1 is 1, 1, 4. And what do we get when we add the second and third rows?
1, 0, 1.
Excellent. So that gives us the final matrix. 1, 0, 1, 0, 1, 3. And what does that mean that our solution is?
X equals 1 and Y equals 3.
Marvelous. So let's, because we're good and we always check. But there's Kim. All right. So our original equations were 4x minus y equals 1 and 3x minus 2y equals -3. We're checking the solution. 1, 3. All right, 4 minus 1, 3 minus 2, -3. And what are we plugging in for x?
The 1 and then -3.
Excellent. Oh, +3, right?
Yes, yes.
Okay, great. And let's see, 4 times 1
4.
and 4
Negative.
minus 3.
Mhm.
Yes. Yay. And then let's see, 3 times 1,
3.
2 times 3,
-6.
good, and 3 minus 6.
-3.
Yay. All right, I want to do the next one. And what we'll do is I'm gonna pause the recording and I'm gonna make myself go away. I want y'all to do example 2. We'll go through it together for everybody who's here. If you're not here, I want you to do this one and take a photo of it. Okay, so y'all are solving -3x plus 2y equals -11 and 4x minus 3y equals 14. And let's pause the recording. Oh, Tyler, will you remind me that I need to start the recording?
Yes, ma'am.
Tyler, to remind me. If I didn't ask somebody to remind me, I would forget. So for those of you who are watching this later, the solution to the system that I want you to solve and send me a photo of is 5, 2. All right. Let's do one more of these. And then we're going to do a 3 by 3, 3 equations with 3 unknowns. So what is our initial matrix for example 3 if our system is -x plus 2y equals -8 and 6x plus 3y is 3?
-1, 2, -8,
Excellent.
6, 3, and 3.
Awesome. I see two kind of obvious ways to get a 1 in the D11. What is one of the ways?
Multiply by 1.
Yes, or by -1. -1 times -1 is 1,
Mhm.
and that will not create fractions. And that's what we're going to do. What is another way that we could get a 1 here? Actually, it's pretty hard to get a 1 there, isn't it? Using row 2. Okay, so let's just be happy with this.
Mhm.
What is -1 times row 1?
1, -2, and 8.
Marvelous. And before we go any farther, what do you notice about the 3 entries in row 2? Is there something about them?
They're all multiples of 3.
They
And they're all
are.
positive.
Then they're all
and-
positive. So if we want, we can make all of the numbers in row 2 smaller by multiplying by 1/3 or dividing by 3. So we're only doing that because we noticed it. It's not going to change the solution, but it'll make the numbers smaller. So we have 1, -2, 8. And what is our new row 2?
2, 1, 1.
Say it again.
Yeah.
2, 1, 1.
Excellent. All right, now what?
We got to get D12 to be a 0.
All right. What is it currently?
2.
That's 2.
It's a 2.
And what can we add to 2 to get 0?
-2.
Excellent. So we have -2 times row 1 plus row 2 will give us a new row 2 with a 0 in the D21 position. And so let's see, we've got row 1, -2 times row 1, row 2, and the new row 2. Let's see, row 1 is 1, -2, 8. What is what is -2 times row 1?
-2. 4. -16.
Excellent. And let's see, row 2 is 2, 1, 1. And when we add the second and third rows,
0, 5, 15, -15.
excellent. And what do we notice about this new row 2 that makes us feel a little bit confident about our addition?
That is going to be an automatic 1 when we multiply. I mean, when we divide it by 1/5. So it's already talking to you. So that's like a step you don't have to do.
That's right. And this -15 divided by 5 is an integer. It's not a fraction. So we feel good about it. And let's go ahead and write this new matrix in. Our new row 2 is 0, 5, -15. And we still have 1, -2, 8 for row 1. Okie doke. And since you already told me what to do next, let's go ahead and write it down. We want to multiply row 2 by 1/5 to make D22 equal to 1. Multiplying by 1/5 is the same as dividing by 5. So what is our new row 2?
0, 1, -3.
Marvelous. We still have 1, -2, 8 for row 1. And what's our last step?
Make the -2 a 0.
Make, yeah, make our D21 0.
All right. And so what can we add to -2 to get 0?
We can multiply the second row by 2.
Very good. So 2 times row 2 plus row 1 will give us a new row 1. And let's see, we have row 2. 2 times row 2, row 1, the new row 1. Where row 2 is 0, 1, -3. Let's see, what is 2 times that row?
0,
0.
2, -6.
Excellent. What is our current row 1?
1, -2, 8.
Awesome. And when we add the second and third rows,
It'd be 1, 0, 2.
awesome. So our final matrix, where 1 is 1, 2, 0, -3. Our So what is the
It's 2 and a -3 for y.
excellent? And let's see, our original negative y equals -8. 6x plus 3y equals plus -8, 6, 3, 3. All right. 2, -3, 2, negative. And times 2 is -2.
2.
And what is 2 times 3?
-6.
Excellent. And -2 minus
-8.
A. And the 6 times 2
12.
and 3 times -3.
-9.
Marvelous. 12 minus 9.
3.
Yay. Before we look at any more of 2 by 2, 3 dimensions. And I have this as a handout for y'all, but we're not at school today. So we're going to see, how does this method extend when we have more unknowns? And all we do is add another row so that we've got 3 rows. B has 3 rows. Our goal is to get 1s down the diagonal and 0s everywhere else. And that means we're going to go in this order. We're going to get a 1 in D11 and then 0s in D21 and D31. Then we're going to get a 1 in D22 and 0s in D11, 12 and D32. Then we're going to get a 1 in D33 and 0s in D13 and D23. So it's the same procedure. We just have one more iteration. Instead of D22 being our last one, D33 will be our last one. And I want to put a caveat in front of this. This will not ever be on a test or a quiz. It's just so that you've seen it, and maybe I'll give you one for homework.
Good, because that's
But this-
too much.
You're gonna have 3 1s out of all the 9. All of the rest of them are gonna be 0s. So 6 0s and then 3 1s, and it's diagonal. Okay.
That's right. That's right. So what is the initial matrix for the system 2x minus y minus 2z equals 2, negative x plus 3y plus z equals 4, and 3x plus 2y plus 3z equals negative 20.
Your first row is 2, -1, -2, 2.
All right.
And then -1, 3, and then 1, and then 4.
All right.
3, 2, 3, -20.
Awesome. Again, as always, our first step is to make D11 equal to 1. But when we have more variables like this, it's really, really important to try to do this first step without fractions. And this is where we haven't done very much switching rows. But do you see that if we switch rows and we move row 2 up, it'll be really easy to get a positive 1 without fractions. You see that? So we're going to use this double arrow thing. I'm going to switch rows 1 and 2, and I'm doing that because I already have either a positive 1 or a negative 1 in that column. So I have -1, 3, 1, 4, 2, -1, -2, 2, and 3, 2, 3, -20. Is the only way to get a 1 doing what we just did? Is that the only
No,
way? That's
you
right.
could have subtracted the row 3 and row 1.
That's right. And yes, so there are loads of correct ways. I just wanted you to see why switching rows might be a good idea sometimes. So we have one more step to get a 1, and what is that?
Add them.
Almost. Would we have a -1? Oh, yes, we could add them. So we could just do R2 plus R1 is the new R1. Or since we have already a -1, we can multiply by -1. Which would y'all prefer today?
multiplying.
Alrighty. So -1 times R1 will be our new R1. So what is our new R1?
1, -3, -1, -4.
All right, good. And we still have 2, -1, -2, 2, 3, 2, 3, -20. And this next step, we're going to think of as happening at the same time. So we're going to write down the commands to make both of the additional entries in column 1 0, but we're going to do them one at a time. The reason why we're going to write them down at the same time is if this was a program, then you would just do 1 zeros, and then the next column 1 zeros, next column 1 zeros, and it's very nicely programmable. Okay, so what do we need to do to get a 0 in D1, D21?
A -2 added.
Good. And what about a 0 where we have a 3 currently?
-3.
All right, so now we've got our commands. Let's go ahead and carry them out over here. So we've got row 1, -2 times row 1, row 2, and the new row 2. Row 1 is 1, -3, -1, -4. And what is -2 times that row?
A 0.
Almost.
2.
Oh, I see, you're adding, you're ahead of me. So I'm just now multiplying row 1 by -2. Okay, so I'm going to catch up with you. So now what is our new row 2?
0. And then 5, 0. And then 10.
Awesome. And now I only have 2 entries in row 2 that are not 0. Why do I feel comfortable about the math I've done so far?
Because you can divide 5 and 10. Well,
That's
you can
right.
divide, yeah, 5 goes into 10.
Yes, exactly right. So we've got our new row 2. It is 0, 5, 0, 10. Row 1 did not change. It is still 1, -3, -1, -4. And we need to find our new row 3. Let's see, for row 3, we have row 1, -3 times row 1, row 3, and a new row 3. Row 1 started as 1, -3, -1, 4, -4. What is -3 times row 1?
-3, 9, 3, and 12.
Awesome. Row 3 is currently 3, 2, 3, -20. So what is our new row 3?
0, 11, 6, and -8.
Awesome. Now, why am I not freaking out that these all don't all have the same common factor? What's different, in other words, between the new R2 and the new R3?
Sometimes the rooms change. The walls change.
Yes, exactly right. The new R2 only had 2 entries that weren't 0, whereas the new R3 has 3. So we know that R3 still has work to be done on it. All right, so we've got 0, 11, 6, -8. And what's our next goal?
To make 11 a 0.
Almost, but we have one thing we're going to do before that. We want to get D22 to be 1. Excuse me. So we always start with a 1 in the next column and then zeros, and then a 1 in the next column and zeros. And if we had another column, it'd be a 1 and then zeros, where the 1 is always on the diagonal. So how can we get a 1 if we've got 5?
Multiply it by 1/5.
Awesome. So our new row 5, our new row 2 is 0, 1, 2. We still have 1, -3, -1, -4, and 0, 11, 6, -8. Okay, now what do we want to do? Now to finish off column 2.
I haven't seen anything like any of that. I mean, if we could see ghosts or whatever, that's great.
Make the a -3 and the 11 a 0.
Exactly right. So we D 1, 2, here's D 3, 2. To make -3, 0, what are we going to do?
Plus 3.
And what row are we going to multiply this +3 by? What column are we in?
2.
So we're going to use row 2. When we're in column 1, we use row 1. Column 2, we use row 2. Column 3, we use row 3, and etc.
Okay.
We're changing row 1 here. And what is the command to get a 0 where we currently have 11?
So you said column, we're gonna multiply row 2 again.
By
11.
positive or negative?
Positive. Wait, negative.
That's right. Okay, now we can carry those out. So we've got row 2, 3 times row 2, row 1 and the new row 1. Row 2 is 0, 1, 0, 2. What is 3 times row 2?
0, 3, 0, 6.
Awesome. What is our current row 1?
1, -3, -1, -4.
Awesome. And if we add the second and third rows,
It's 0. Wait, no, 1. And then 0.
good.
And then -1 and 2.
Excellent. All right. And let's do the same sort of thing for row 3. So we have row 2, then -11 times row 2, row 3, and the new row 3, where row 2 is currently 0, 1, 0, 2, and row 3 is currently 0, 11, 6, -8. Okay, so what is 11 times row 2?
0.
-11, yes,
Mhm.
yes, sorry.
0. And then -22.
Awesome. And when we add the second and third rows,
0, 0, 6. And then -30.
excellent. Why do we feel sort of comfortable about our arithmetic because of this new row 3?
Because it's divisible by 3.
By 6.
That too.
So yes, if we divide by the element on the left side of the dashed line, if we divide the right side by the left side, we still get an integer. We don't get a fraction. So that's very good. And our new matrix, let's see, we have 0, 0, 6, -30, 0, 1, 0, and 1, 0, -1, 2. Have we finished the second column?
Yes.
So what's the next thing? Very good. What's the next thing we want to do?
The 6 and the -1 have to be zeros. And then the middle one has to be, wait, no. The 6 has to be a 1, and then
Yes.
the other 2 have to be a 0.
That's right, exactly right. And how can we make the 6 into a 1?
Divided by 1 over 6.
Exactly right. So our new row 3 is 0, 0. What is -30 divided by 6?
-5.
Awesome. We still have 1, 0, -1, 2 for row 1, and 0, 1, 0, 2 for row 2. And we just have one tiny thing left. What is that?
You the -1 has to be a 0.
Excellent. And what's a way to do that?
So you're going to add or multiply that row 3 by by 1.
Yes, exactly right. And since it's by 1, I don't have to do any work. I don't have to write it, but we can write it. It's also just fine. So we've got row 3, row 1, and the new row 1. Row 3 is 0, 0, 1, -5. Row 1 is 1, 0, -1, 2. And what is our new row 1?
1, 0, 0, -3.
Yay! All right. So our final matrix, 1, 0, 0, -3, 0, 1, 0, 2, and 0, 0, 1, -5. And you see, we do have ones on the diagonal, and everywhere else we have zeros. And that means that our XYZ solution is what?
-3 for the X, the Y a 2, and the Z a -5.
Excellent. And let's check. 2x minus y minus 2z. 2x minus y minus 2z equals 2 negative x plus 3y, negative x plus 3y plus 4 and 3x plus 3 equals 20. And our solution that we're putting in is -3, 2, -5. So for all the x's, what n? They use for all
A -3 in the first one, and then a 2, and then a -5.
right. 2 times -3.
-6, -2.
Good.
And then
-2 times -6 minus 2. Six minus 2.
-8, and then plus 10 is 2.
And -3. Three. 3 times 2. And adding a negative, subtracting 5. 6 plus 3. And minus 5. Perfect. We have one more. What is 3 times
-9,
and
and
2
then 4,
times
and then -15.
-9?
Once -5,
-5 minus.
-20.
Yay. So what's important to me that you understand here is that when we add an unknown, we just repeat what we've been doing for yet another column, where we start off by getting a 1 on the diagonal and zeros elsewhere column. Then we move to the next column, we get a 1 on the primary row, zeros elsewhere, and we move on 1 on the primary diagonal, zeros elsewhere, and then we have a solution. Our final system looks like. And the main reason why, see why this, because it's really systemized and therefore programmable, and to as many zones as you you have to do one replay. Solution is there. I'm going to video. So if you're watching this later, then please problem and send me a screenshot. And if you're here at, please talk to each other, because I'm listening.